Let me try something here.
By the way, if you hear somebody snore, it's not me. It's my
Yeah,
little doggy.
Yeah, looks like I'm able to share the screen, right?
Yeah, you're sharing your screen right now.
Okay. Then let me stop sharing for a second, and then at least it works.
And there's Craig.
Hello, Marcel.
Hi. Normally I would say long time no see, but that's not the case.
Not the case.
This is 3 times in 2 days.
I guess a lot's happening. A lot's happening, right?
It was yesterday, and it was at the PMI. Were you
The
also
PMI earlier today?
earlier today?
Yes. Yeah. That was actually my first meeting to attend for PMSE integration.
Yeah, mine also. I was already a member for many years, but somehow I never knew how to get on board on those meetings. And since they are using that dynamic mailing list, it's working.
Uh-huh. Oh, that reminds me, I need to remember the confusion we had about my email. I need to just check that still. It's an email account I don't use very much for INCOSE stuff, and so that's why I missed it. I'll have to go and make sure that my invitation to the future meetings are using my INCOSE address.
And okay, yeah, that's better. You can change that in your personal page at incose.org.
Well, my personal page, my profile is set up for that. Yes, should be.
And if you want to forward your incose.net email, I think there are some guidelines how to do that, how to fix that.
Okay.
Barclay Brown, not to confuse with Dale Brown, but Barclay, he knows how to do that.
That email today, please. And then Pat Alderton, when her money, it's a, yeah, so you're gonna terminate, it's a term.
Hey, Marcel, is my audio working?
Yes, it's working.
Yes.
Great. I can't get my video to turn on.
INCOSE Tech Ops.
Okay. Yeah, I tried to change it. There's something wrong with my Zoom controls because when I go to rename, it just sits there and does nothing, and I can't turn my camera on either. So I don't know what's happening, but let me try again here. This is just there we go. Backups. All right, good.
I have some background noises, so I will mute my mic.
Welcome, everybody. We're just gonna wait another minute or so. Apologies, I can't seem to get my video working in this new Zoom thing that was loaded onto my laptop. So it's probably a relief to everybody else, though. So there you go.
Hello, Dale.
Hello, how you doing, Mike?
Okay.
Every time my friends in IT play with my machine, they break something.
What did they break?
They broke my Zoom control panel. I can't turn my video on. So I'm
No.
I'm trying a few drastic measures, like I'm
Let's see if
unplugging
mine
my
turns
camera
on.
physically.
I turn on. Okay.
Yeah, I'm gonna try the old if all else fails, unplug it and try it again. Crude, but occasionally.
But most importantly, does Oliver's work?
Yeah, we had him up, and I'm not sure if he's back. He had to go away for a sec, but are you back, Oliver?
Yeah,
Oh,
and we
great.
already
Okay.
tried screen share, so it seems to work.
Excellent.
Are you still in California, Oliver?
Oh, I was always in New Jersey. I just
right.
traveled a lot.
Okay. New Jersey's better, right? Yeah.
Well, let me put it this way, there's always pros and cons wherever you are.
Yeah.
Well, I guess we could probably get going now. Can you guys still hear me?
Yes.
Mhm.
Excellent. Okay, I was afraid I might have also broken my audio. So I'll go ahead and introduce Oliver, and then we can jump right into it here. So welcome everybody. This should be an excellent presentation, as is typical with our presenter. So Oliver is a passionate SE practitioner. He's a technical fellow, project manager, and he's the U.S. Global Technical Excellence sector and practice lead on systems engineering, communication, and controls for WSP USA. Oliver is of course, an INCOSE recognized expert systems engineering professional, and also PMI certified project management professional with 25 years of extensive international and domestic experience in systems and software engineering, and has worked in leading systems engineering, integration, and testing roles on large systems around the world, like transportation infrastructure. Typically gets you into. Oliver's currently spearheading the application of Agile MBSE to intelligent transportation systems, and the tradition from traditional document-centric engineering to improved model enhanced systems engineering approaches in legacy transportation projects. So with that, Oliver, I'll turn it over to you.
Yeah, thank you so much, Dale. I guess what I should or could do at the beginning. So first, let me share the screen over here, and then maybe show the camera for a second. Can you tell me whether you can see the screen?
Yes, the screen just popped up.
You're sharing the screen. Okay, and then maybe once for a second. Let's see.
There he is.
I can't even see myself, so I'm just saying hello, and then in order not to distract you from let's say the fancy user interface, right? Then anyway, let's go to the actual presentation. So so first, Dale, thank you for inviting. Some of you may have seen already the presentation. It's I presented at the IS 2023 in Honolulu, which was obviously great. It's about I have spent of my career about 15 years now in transportation projects that also include infrastructure. And so it's sometimes difficult to differentiate between transportation infrastructure projects. Anyways, and my background is really more in the software engineering portion. Anyway, so let me just jump in. Of those 15 years, I worked more than 10 years on high-speed rail, and that's basically a summary of those 10 years. And I even see some familiar names from high-speed rail, so welcome without mentioning names. Let's see, moving forward here. It's actually a pretty long presentation, so I'll have to speed up a little bit. If you have any questions, you can always reach out to me. So the way I structured the presentation is first to give a little bit of a background introduction about the motivation of why am I doing, why the presentation. Also a bit of how infrastructure projects, the one I was working on, high-speed rail, I'm still working on, but not as much as I used to. A little bit on the background of how this all works in the US. And then also important is what we are trying to convince non-systems practitioners to apply systems engineering. It's also, I have some advice for actually systems engineers from other, let's say, industries entering the industry, because it's really, really challenging. Anyway, I will give an overview, talk about some lessons learned of the last 10 plus years. And then I'll go into some more details of if I ever could or should or whatever, what I recommend. I'm doing this again. This is what we recommend doing. So just as an overview, some of you may have seen some of those presentations. This is all about high-speed rail. I started presenting in 2012, entering a brave new world, all the way to last year on digital threads and large system of systems. You can almost see like this excitement curve. I think there's a name for that, but basically at the beginning we were very excited, and then we had a little slump in the middle. I don't need requirements. I know what I'm doing, right? In San Diego, we do not have a problem, meaning is INCOSE, go away. We don't need you. And then it really settled during the last couple of years, and it became more and more accepted. Anyway, so the background is, so we have lessons learned from high-speed rail from what's called construction packages 1 to 4. And they basically come to an end now, more or less. And so what we wanted to do is to take all the lessons learned and refine our systems engineering requirements we have imposed into those contracts. Then there were 3 new contracts issued in 2022 on primarily design first. And somebody has some background noise. I don't know. Could you please go on mute? And then I don't know who is that, me or is it somebody else? Anyway, and then we also what happens now is the High-Speed Rail Authority has now changed consultants, meaning is WSP is actually finishing fairly soon. And so there was also a good opportunity to basically write it all down, right? Whatever we had done in the past, memorializing it, do a handover, right? Documenting our hands-on experience. And then also what I strongly believe in, whatever we learned is as a $1 trillion US infrastructure bill, whatever we learned as part of infrastructure, right, could, in my eyes, easily be applied to those projects as well. Anyway, so high-speed rail, right, is really the project I'm talking about. Initially 119 miles of 225 structures, now extended to 171 miles, close to 300 major structures. And some of them have been completed, like river crossings, under crossings, meaning this is the future Fresno station, roadways going under, trenches, right, viaducts, as you can see over here. And so let me just, what I was saying earlier from the excitement part. When I started in 2012, 2014, the presentation you see here is from 2014. The idea was to move away from paper. What you see here is from one of my prior projects, that the whole safety assessment was done by literally using paper, and not even PDFs, literally scribbling on paper. Yeah. Then secondly, revolution, right? Could we please use requirements when we do design reviews or construction reviews, meaning is use actual requirements and traceability matrices. And then wouldn't it be great to have a holistic systems approach, right? From end to end, from all the control center to all the field, including what looks like almost like a sequence diagram in here. And then 2014, dreaming is like, woo, one day, right? We might be doing MBSE. So that was kind of, the hype cycle, I think is the right word. And then this is what happened, right? So this is truly a picture of construction in the field. And look at this, there's some couple of wooden beams, a little bit of concrete blocks, some steel, somebody sitting on top and drilling a foundation. And I think a safety guy, a safety professional would have a field day with all the tripping hazards here. Anyway, yeah, you might actually fall some, dozen feet into, anyway, yeah. And Dale, I think you actually mentioned that the other day. So that's a study done by McKinsey, and they're saying, hey, the US infrastructure industry is not really good in learning something, anything. It's actually getting worse. Yeah. So if you compare this during the last 80 years, it actually got even worse, right, over time. So all the other industries really have tremendous learning curves and improvements in efficiency, but not so much the infrastructure industry. And that is literally what you're dealing with if you're a systems engineer and trying to do something about it. Also, as I said earlier, some advice for systems engineers that actually enter the US transportation and or infrastructure industry, the tremendous disincentives for SE. And so what I'm saying in here is any construction or design construction firm proposing additional and unsolicited work, such as systems engineers, an upfront investment in a firm fixed price and low bid environment will be at a competitive disadvantage due to increased bid costs. So everybody will say, go away, yeah, and don't do anything. And so here are a couple of things that I learned during the last 10, 15 years. And I really, the actual paper which the presentation is based on has like 3 pages with more detail. So if you're really interested, then please read up or contact me. So the first one is the nomenclature terminology, right? Every industry is doing the same thing. They have some secret handshake. So you need to know the language. You have to learn it because you are trying to sell something, and so you have to speak the language. Then the word systems engineering, I stopped using the word many years ago because it's considered not applicable, because it's practically always misunderstood as engineering of systems. They're saying, oh no, we're not building any systems, we're building infrastructure, so go away. Yeah. The whole idea of a systems engineer or integrator doesn't exist. It's all the clients are typically highly functionally organized, right? You have architecture, structural teams, you have electrical, mechanical, communications, you name it, but there is no systems engineering function most of the time. And then stakeholders are typically somebody else outside the project, like third parties, like I don't know, gas lines, electric utilities, or regulators. Operations maintenance, that is something that literally in the eyes of infrastructure happens after construction is done. So nothing to worry about right now. Yeah, literally taken care of by others. And the ones familiar somewhat with the US industry, it's typically called design bid build or design build, and sometimes also design build, operate, maintain, which is exactly to the point here, right? It's at the end. Requirements, nobody does requirements. They are expected, and I'm phrasing literally words I heard just fairly recently, that people are expected to know the requirements or be familiar with. You remember the paper, I know what I'm doing. That's literally the attitude of 90% of the people. Architecture, if you think of architecture like something that we do in systems engineering, forget about it. That's basically designing buildings. That's architecture, like a station or something. Yeah. Again, integration, C-O&M happens at the end, so nothing to worry about right now. And V&V is confusing the heck out of people because the industry is using what's called quality management, right, with inspection testing, design reviews. So that, if I ever could, I would go back in time and travel. I would never, ever use the words again. Also, firm fixed price, low bids, meaning is the cheapest bid wins. So everything that costs extra, like systems engineering, is going to be removed from the contract. Everything you forget, it's going to be a change, and it's going to be big ticket items. And then I stole this term from software engineering, the whiskey syndrome, right? Why isn't SEMI coding it? But it's easily applicable to construction. And so progress, there's never ever will anybody ever say, stop it right here and let's fix the issues. Always, oh, we're going to address it later. Yeah. So these are the kind of things you really need to be aware of if you work in the infrastructure industry. And then also from this paper here, right, if you ever want to do something about it, so describing the key players in the industry, the owner representatives, like the consultants, the design consultants, construction managers, the actual construction firms, the ones who really could make a dent or make a difference are the actual owners, right? Or the owner representatives, like consultants, like our firm. So if you ever have an opportunity and you have an agreeable client, then you can put into the contract to basically level the playing field, right? So now everyone has to offer something, and you can enforce it. But it will be really difficult if you offer something from bottom up. It's going to be taken out. That's really the statement here, right? Owners have really the opportunity and authority to actually request systems engineering, but then again, they need to be aware of what it is and what it does and what it benefits them, and then actually, agreeing with it. Lessons, that brings us to basically the lessons learned. So what I'm going to do here is quickly show you what happened like 10 years ago, what requirements we developed, and then what happened to those requirements, and then what are the lessons learned, and then basically integrating them into the recommendations going forward. So 20, it's probably fine print, but can you see it says March 12? So that was one of the initial contracts, CP1, Construction Package 1. So the documents itself are even written before, like 2011. I wrote those documents, and it was about verification validation. Just as a background, our program director had worked in the UK, had heard about, oh, this is something cool, we want to do this in high-speed rail, and then they needed somebody who was doing it, and I was doing it. So basically that is how B&D came all about in high-speed rail. And so I wrote this in, oops, let me go back for a second, as actually, people familiar with it, it's a construction spec format. It says products, execution, right, introduction or overview. Anyway, so it talks about V&V and requirements management and design and interfaces, and then even using requirements management tools. And people familiar with tools will recognize what it is over here. Anyway, we told the design builders, this is what you have to do, right? This is what we wanted to do, how to do it. And then we even put in what's called a template for requirements traceability matrices by having the requirements over here, and then during design, right, show me that you did it. There was even during design, because it was design build, requirements management to be done, and then design verification, construction validation, testing acceptance, and then showing examples from very easy requirements, specific enough, like super elevation, which is really the difference in rail heights, with specific numbers, right, and so forth. Anyway, we put this in, and so some of the requirements were, especially for safety, for example, we had internally done what's called a preliminary hazard analysis. And so, for example, somebody said, oh, somebody could throw something from an overpass, and then this is not acceptable, right? And then there shall be intrusion prevention measures like fencing at the overpasses. And so what we did is then during the design, right, we could see, oh, there are the fences. And then during construction, we could actually see that was done. And so that's the whole idea, right? Going from requirements, making sure during design and construction that you actually meet the requirements. What a concept, requirements-based engineering. And then this is an example of what we call certifiable items list. It's a real thing. I didn't make this up. In the civil world, basically you identify all the requirements. In this case, can you see in here? This is an actual example from one of our contractors. It would say, can you see? This is the ID. It says install intrusion prevention fencing, right? And then they would give us, this is coming from what I just showed you. And then we would get references to the design submittal, and then we would get references to objective evidence during construction. And then we did the same thing with integration, interface management. So we did some program level requirements or system analysis, identifying all the key interfaces. There's a whole different presentation and paper on the topic of integration management. But one of the, can you see it says here maximum grade and face breaks, meaning this is an example of a train set in Germany. And going up a steep incline, as you can see. And then obviously you cannot really cut the power in here, which is what a face break is. Electrical systems are not really one long electrical system. They're broken up into subsystems. There have to be breaks in between, and you really don't want to have them where the train has to go up a mountain, right? That's the whole idea. And then what we did is we identified not only the list of interfaces, we identified, then had a table in here. We have global identifiers. We even pointed out where you can find the requirements in our design criteria manual, right? Spacing of traction per facilities and maximum grades. And so it was even but taking the contractor's nose and sticking it right into the requirements, saying that's what you have to worry about. And then at the end, and it's without naming names again, so we basically pushing for interface control documents. That's the one exactly. We just talked about the face breaks, right? And then what you would do is you would excerpt the actual cell. We just talked about the certifiable items list, and all the submittals it points to, right, would be attached to it. So now you would see the actual drawing and say, hey, there's a traction power substation. And then there's a face break, there's the grades in here, making sure they actually meet the requirements. And then this would get a cover page and signed off, and then you would have like a 3-step approach signature page, the actual interface of references to all the design submittals, all the objective evidence, and that would become what's called an interface control document. And it's quite challenging, I have to say. Yeah, the same is done for all the safety and security mitigations. Anyway, that's something that actually that works, but it's really challenging to enforce it with the contractors. Anyway, key lessons learned from those 10+ years. Let me just show you first what the issues were and the challenges. So we had some real issues with basically, I always refer to willing and able, right? The ability and willingness to implement SE, because it was completely new to the industry. People struggled. There was the ability, but sometimes even you had design builders who just said, I don't do it. Yeah, basically the willingness. And so what it resulted in is an incomplete, incorrect, inconsistent, and or delayed SE implementation. Let me see whether I can actually find my mouse better here. Pointer options. Okay, visible. And then also there's a whole idea of in the industry in the US of leaving it to the contractor. Just tell them already what you want and leave it up to them. That doesn't really work in a program, and it's really difficult. When you buy like for a car, a seat and a hood and a steering wheel, and you can't just buy those pieces and then just saying, well, whatever wheel you come up with. But that's unfortunately the mentality of a mindset. So of course, right, every contract or every CP contract developed things differently. Of course they did. But anyway, it takes really like a long learning curve for many in the industry. Then governing requirements. You will see, I'll talk about requirements a bit later, is those contracts have dozens, if not hundreds of documents with easily 10,000 plus requirements. Yeah. And so which requirements apply is one of the most painful discussions all the time. So this is something that needed to be addressed. Then the core concept of breakdown structures. I mean, this is what the architecture is all about, right? Like an MVC, the system structure seems to be super complicated to understand in the industry. And then RAM we had literally senior design managers from contractors saying, what is RAM? They have no idea. Yeah. Anyway, so here's what we did, right? And basically lessons learned. So we took all of these lessons learned of the challenges. And so we updated that VVSC document, the one I showed you earlier. I will show you again a little bit later. And now we call them system development lifecycle documents. So we added training requirements, additional detail of process. We identified milestones and tied them actually to payments in the tracted systems contract. It became a standard document. We even created requirements management tool handbooks, and we created a model, not like model-based systems engineering, but basically, I'll show you later. Anyway, so we took all of those and created basically an updated document with way more detail. And then also we had issues with V&V during construction. There was a lack of appropriate inspection test planning, again, without being too specific. One of the contractors had 90% plus of the requirements applicable during construction and no inspection test planning documented at all. And everyone felt that was just fine. Yeah, who needs requirements in the first place? Anyway, independent V&V, meaning is we follow the concept of a European notified body. So we have some independent third party. And then change it's a pain, really. It's because changes happen all the time with requirements, with deviations, with design in the field, and it's really tricky already to keep track of all the changes. And we talk literally thousands of changes, you know. And then also at the end, let me go back to certification. Nobody seems to think about it ahead of how do we declare victory? I mean, when is done? Yeah, when can we certify that everything is compliant? Again, right, we updated the SDLC document. I'll show you in a second. So going to the actual recommendations now. So what we did is we refined and tailored the systems engineering requirements that I showed you earlier that we started like 10 plus years ago. We developed that SDLC or systems development lifecycle model and also identified the phases. And then I'll talk through every single phase and tell you what I would recommend anyone does. So again, you remember this was the original when we started out initial SE, and this is now what I refer to as the SDLC, the Systems Development Lifecycle. So we kept all the process requirements in here. So the traditional, and SC stands for self-certification, by the way. So verification, validation, self-certification. but we added SDLC phases, meaning is the typical, you will see the V model, right? We say requirements, architecture, preliminary design. And then we also added management requirements, right? That was the actual management plan up front. And then we also added deliverables specifically identified by phase, so making it clearer of what we want, when we want it, how we want it, and the likes. And then if you ever wonder where those terms come from, when I wrote the paper, the SE Handbook 4 was still governing. Can you see it says here technical management, it says here technical management, right? It says something like specialty engineering down here, cross-cutting. So I was trying to tailor it after the INCOSE handbook, also make it easier for systems engineers to onboard the industry, but then tailor it specifically to the industry. You remember the language? So we wouldn't call it like final design in this case. I call it ready for construction, deliverables and whatnot. And then also recognizing is you can't really throw the whole book at people new at this. So we actually came up with 2 different versions, like a light version, so to speak, of SE and a more sophisticated version. So everything civil works or infrastructure, right, is a little shorter, just if you can see over here. And then everything that really is more complicated, like signaling system, communication systems, train sets, or likes, would have to follow the more thorough system engineering requirements. What we also did is, now that we had the book that would actually describe requirements, right, of what to do, like capture the executed contract. And then we actually came up with, that's literally what we call the model, in a requirements management tool, and then showing how this would be done specifically, not only saying do this, but giving examples to have a more standardized process of doing things. So let's quickly talk about the model, right? Everyone knows the V model. And so what we did, that SDLC document was not only for systems engineering requirements, it served as the whole purpose for identifying phases in the program, right? So phase 1, phase 2, you name it, and then you had a work breakdown structure, identifying all the deliverables, and then assigning the deliverables to all the different phases, and then assigning all the deliverables and the milestones to payment milestones. And then you can even literally create a schedule out of this. So that's the whole idea of really having structure in the program. And this is, if you ever get your hands onto one of those documents, SDLC, this is how it looks like. It looks more like a U, but it's kind of a V to have some room in here. And if you can see, right, it talks about design and build on basically following the industry, then phases like requirements analysis, design analysis, preliminary design, ready for construction. Again, this is the one for infrastructure, following the industry practice to the degree possible, to not basically make it too awkward. Then you have reviews like system requirements review. You have baselines like system requirements baselines, and then important, right? So this is, let me go back for a second. Those phases like requirements analysis over here would now be described in detail. So that's nothing more than a graphical table of contents, so to speak. And now you would go into the document and it would say requirements analysis phase in here, for example. And then you would have a section that describes the requirements. And then you have a section on deliverables right at the end. So you would have requirements analysis phase with deliverables. And then you would have the deliverables listed. And then you would have requirements in detail for those deliverables. So very structured, top-down, right, decomposition and whatnot, both from a project management and the systems engineering perspective. Also, what we did is we have a whole concept of breakdown structure. Remember, was one of the key pain points we had. So from a systems engineer, right, it's easy. You say system, subsystem, system element, and LLIU, lowest level replaceable unit. But then we even tailored this to the specifics. Can you see with color codes over here? To infrastructure. For example, it would say the system is a project, and the subsystem would be like aerial structures. And then, as you could see already, this is an example of an actual design of an aerial structure, Fresno River Viaduct. And then, so this is basically applicable over here. And then you would go the next level of detail, like superstructure, right? Is everything up here? The substructures, everything down here. The bearings, can you see it actually says bearing over here? And so we're trying to really guide any systems engineer towards, or the civil guys towards doing this the way we envision this. Anyway, I see the time is running, so let me hurry up. So now coming to the actual phase-by-phase description. because I know it's a lot of material. I will focus on the ones that are highlighted in blue. So I always, for each phase, I identify the key purpose, the deliverables, the milestones, and the key recommendations. So mobilization is really happening at the beginning, right? And I encourage you to read the paper in all more detail, but basically right after you say, hey, lucky you won the job. So that's what's called notice to proceed in the US. And then this is where you want to have the systems engineering management plan. We dared to actually call it systems engineering nowadays. There's a milestone attached to it. And then you remember what I showed in blue here. This is, let me just spell it out anyways. This is where everyone still is in the honeymoon goodwill phase. This would be the time to document any agreements, specifically in the SAM, right? So request detailed management plans describing how the contractor plans to execute the project, all the deliverables, activities, timelines, processes, templates, you name it. And do not allow the contractor to just skip over this. I think there's a famous saying, failing to plan is planning to fail. Coming to requirements, that was the next phase. You remember I told you earlier, this is going to be, I will talk about requirements. So this is an actual contract, construction package 1. These are all the links to all the documents, and this is not even everything, yeah? But can you see design criteria manual, like 7,900 shell statements, third-party agreements, 550 pages, standard specifications, scope of work, you name it. You will easily have 10,000 requirements plus. Actually, one of the contracts, we have 25,000 requirements. And everyone who has ever worked in the industry will probably just nod and start crying, I guess. Yeah, it's a lot. So what's the key purpose and activities, deliverables, right? Review milestones. So let's just focus on the deliverables. You want to create what we call a contract requirements baseline. I'll show you on the next page. Perform what the industry calls a design and code analysis report. For example, if you have tunnels that refer to, I don't know, let's say fire codes and the likes, or building codes. You will want to identify a requirements baseline of what exactly are the requirements you're going to design to. And you want to think about already testing, inspection testing, and how you want to certify at the end of the day and how you want to hand over. Those are the key deliverables. Let me show you what we mean by this. So the contract documents, right? You remember what I just showed you with all the hyperlinks? You want to capture those and identify which requirements you want to manage. That's what we call TCRs, for technical contract requirements, because we really want to focus on the actual system requirements, the technical ones. NCI for critical items, everything that is safety, security, interface related, in some contracts, even environmental, everything that we will require certification at the end, we captured separately even. Then also what we call the design code analysis report, the DCA, right? Design code analysis report. Because quite often there's just a reference, follow all the whatever AASHTO standards or whatever, all the IEEE standards, for example. And you say, whoa, wait a second. Yeah, so you have to be specific, which standards, which year, which sections, right? This is really what you do in here. And then you roll this all over to what we call the TCR and CI from here over here, master list now. So that basically becomes the actual baseline to manage. And from there, you want to also identify already, how am I going to verify and validate, basically the V&V methods, really only the 4 different ways of inspection, testing, right, demonstration, analysis, and also how am I going to plan to certify. That's literally the phase 1, the real first phase of what you want to do. Having said that, here are the key recommendations. Let me just roll them all down because time is ticking. So do insist on formal requirements management. So you can see with do and do not, yeah? Don't let anybody convince you that they know or familiar with thousands of contract requirements. I mean, I can barely remember a shopping list with 3 items. How dare somebody else claims they can remember? Use a risk-based approach, meaning is you will not manage 25,000 requirements. Focus on the one that are close to your heart. So we initially started off with TCRs, but even then, there will be a subset of those requirements. Then lock those requirements down the baselines, right? For each requirement, that's really, I encourage you. We did this initially without. There will be huge discussions at the end of what needs to be inspected, tested, what kind of inspection method is going to be used. I'm sorry, somebody is some background noise. Do I have to? Anyway, and also do not accept, this is really important, yeah? Do not accept any design submittals before this phase is over. Actually, you will see, I'm going to say this in the next phase as well, because contractors want to go straight to design. Requirements, again, you remember, I don't need requirements, I know what I'm doing. So coming to the design analysis, the reason why it's called design analysis is because the industry really has a lot of analysis to be done, whether it's hydraulics analysis or geotechnical analysis. So anyway, yeah. So at this point in time, what you want to do, focusing directly on the deliverables, come up with a breakdown structure. So the closest thing would be in systems engineering, the architecture. And then also everything is super site specific in construction, right? Everyone will say, oh, this bridge at this street. So people think in terms of sites. And then you will be flooded with submittals. So think of as submittals as well. So what we call the site and submittal breakdown structure. Then there's a lot of engineering analysis to be done. For example, a RAM analysis we asked for, or the design code analysis, right? You remember, or there will be type selection reports. There's a ton of things to be done by the design builder or contractor, which actually result in your requirements. And then based on the breakdown structure, you want to take all of those requirements and saying these belong to whatever, like system element XYZ. And then also at this point in time, we actually asked for more details on how to inspect and test. So at this point in time, we actually asked for planned objective evidence going forward, meaning is if you say, I have I don't know, my track alignment, you will say, well, that's great, you want to inspect it. But tell me exactly what are you going to give me for objective evidence? Because if you don't at this point in time, there will be huge discussions later on. Anyway, moving on, let me show you how this would work, right? You remember level 2 already, the actual master list of requirements. So now what we would do is to say, hey, we have system level requirements and we have subsystem level requirements. So system level requirements would be, for example, design baseline reports, hydraulics reports, RAM reports. And then for the subsystem, you remember we have earthworks or embankment, aerial structures, trenches, tunnels, you name it, third parties like utilities. So is it really too much to ask for, to think of, you know, of those 25,000 requirements, which ones apply to, let's say, aerial structures only, making the amount of requirements a little smaller? It's quite a challenge. Anyway, that's what we're asking for, right? So first have that breakdown and then take the requirements and assign them to your breakdown. And then go the next step. And then the system elements, you remember from what we looked at earlier. So now you have MSE walls, or you have embankments, or you have bearings, or superstructures, you have utilities like gas, electric, and all of those, I can swear, will come as submittals to you. So you better know which requirements apply to those submittals. And then you even go one level below, right? The LLIUs, for example, you will have, you will have submittals, for example, for bearings. So you really want to be able to have that breakdown, you know which submittals you're going to get, and you know which requirements apply. And that will then later on be applied to sites. Anyone familiar with MESE? That is what's called the elements of definition, basically the type design, the typical design, which will then be used by sites and submittals. Showing an example, typicals, right? Like an overhead. And can you see it's like, it says avenue, 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 and then overhead, overhead, overhead. So basically, you really have to do the work only once, right, for a typical overhead, and then I'll just apply it or use it all the time. So let me show you, this is a real Avenue 10 and CP1 country, what was built. And then this is where the fun begins. You're not getting one submittal. Beware, you get structural submittals and civil submittals and geotechnical submittals, because that's you remember how the engineers are being structured. And then you get some drawings which apply everywhere, but not also here as well. And then you have some sub-consultants that do something. So you will be flooded with submittals. And again, you really need to understand which submittals you're going to get, for which sites, which requirements apply, because if you are being asked to review, how would you review if you really want to perform requirements-based review? And then you do this with a rinse repeat, right? You get draft and final reports, you get 60/90 RFC calculations, drawings, you get early start of construction, right? You get design and field changes and as-builds. Again, you will be flooded. So you better have a process in place. And then when you come to construction, then this is one of the CP4 contracts over here, what used to be broken up in 4 different what's called sections. And then you had one design submittal, which obviously was bigger than only those sections. And then those sections over here would align somewhat with construction sections that were called quality models and data packs, but not perfectly, because really people have difficulties thinking ahead. I hate to say, yeah, it's always just today's problem, and then tomorrow is tomorrow's problem. And then obviously, right, this is earthworks, and then this is an area structure again, and this is earthworks again. So you constantly feel like you're playing a shell game, and you're losing track of a ball. And then you have all those third-party submittals in here, and so all I can tell you is really difficult to keep track. And then in construction, also, they built this from a bottom up, right? They call it stages. That's an actual construction staging plan from a design builder. So they built basically foundations, right? The abutments or wing walls, and then the superstructure, and anyway, yeah. And that's a real thing. That's how it looks like now after it was completed. So this is now what I was trying to say here. This is the site submittal breakdown structure, the SSBS, right? So you have design. So here are the submittals we talked about. The sites where type submittals are being used, like let me go back, aerial structure number 1, number 2, and then roadway overhead and the likes. And then you have the actual submittals, right? So an earthworks comes with all those reports, and then, for example, you have system level reports, and then you remember from the color coding before, you have a system element and LLU type of submittals, and then they come in all different levels of progress. And then in construction, you have the sections I just showed you, and then they come with all kinds of detail. And then even the construction, ideally, comes to construction stages. So again, and this will be like left and right, and you will not know what will happen to you if you don't have a plan in place. Key recommendations, let's go in here, focusing on the blue ones. Really decompose the system level requirements in smaller, better manageable, and typical requirement subsets. The SBS and SSBS becomes the basis for those requirement subsets, literally the system structure. Then any requirements from any analysis you're doing really have to be incorporated, and then become, it's like a duh for systems engineers, but still, yeah. And then also, right, continue with the detailed planning for the actual testing at the end of the day with planned objective evidence. And again, do not accept any design submittals before this whole analysis is being done. So basically, you do the requirements analysis first, and then the design analysis. And that takes so much time and work. And in the meantime, people will be very eager to actually go ahead. So let's see, I want to answer some questions. So let's fast forward here. Preliminary design, this is really like the 60-90% design. Let's see, this is what I was showing earlier. You develop typical or type designs, right? And then what you do during the actual site specific, you take those, apply them. It's like pick and choose the set of requirements that apply to your site. Those are requirements, and then the actual submittals come in, right? You want to document them in submittal logs, trace them all to the actual submittal. Let me show you over here. So you would create a traceability matrix, and you would have requirements listed over here with IDs, with the source document, the sections, the actual requirement. You would have already the planned objective evidence, right? Which V&V method you have for each requirement, which objective evidence you're planning to use, and then the actual submittal and the actual trace to the evidence. And the evidence happened to be a design submittal or construction submittal. And then can you see this is an example, a real world example of operating speed, 250 miles per hour. You would say that's submittal XYZ, and then you would say these drawings actually show that, that the requirement was being met. And then you would have two lists. One is the submittal log. One is the actual log for, it's like a meta log if you want a meta document for the actual submittal. Here the drawing list, right? And then one of those drawings would actually show the 250 miles in here. So you establish traceability from the requirements to the submittal, to the drawing log, so to speak, right? And then the drawings would trace directly to this evidence showing you that you actually designed 420 miles per hour. Let's go to key recommendations. Basically, do not accept any design submittal before you kind of hear what I'm saying, right? Repeat this over and over again. It's like do the requirements first before you do design. Do not accept any preliminary submittals for elements that have not been previously identified. we saw this over and over again. All of a sudden you get a submittal and say, wait a second, what is this all about? And why do we even get this? Insist that RVTMs and tilts, right, references, traces are being provided to the lowest practical level. It's not helping to say, well, it's somewhere in the submittal, then it's like, really, it's really an insult to you if they're doing this. Check that all the referenced and traced objective evidence actually demonstrate compliance with requirements like the 250 miles per hour. Do not allow data dumps, meaning is giving you 500 pages of document if you really need only one page, because they try to distract you and not, basically it's a denial of service attack on you to not being able to effectively review. And do not allow reference to other submittals that would result in spaghetti tracing. Final design, surprisingly, right, where people say this is the biggest one, is pretty much the smallest one, because all you do is you keep doing what you were doing based on the work you have done before. In this case, remember, we have site-specific requirements. Now going from preliminary design to final or ready for construction design is really only addressing more requirements in the same site. And the key recommendation is pretty much the same as for the preliminary design. Be aware that ready for construction can mean quite a lot. There might be just foundations or early start of construction. So you might be in the middle of design and people say, oh, I'm ready to dig holes. Yeah. So be ready for that. And then apply a trust but verify approach. So we have certifications, the trust part, but we're saying, hey, please, we want to verify, meaning is show us the proof, please, in form of RVTMs and cells showing us for each requirement the applicable evidence. And then, since this is really ready for construction, do not allow any critical engineering analysis like RAM to slip beyond preliminary or ready for construction phases, because there's no way you will ever be able to check the requirements into whatever you constructed. Manufacturing construction is really the actual construction. Let me fast forward here. Again, right, the same thing. So now for the same site, you go from preliminary design to ready for construction to actual construction. Just more requirements you're addressing for the same site. Should be the same concept. No rocket science. Let me see here. Clearly define the construction stages and associated requirements. You remember the construction stages. If you build from the bottom up, identify the planned objective evidence. The construction phase, the middle demonstrate compliance. Be clear of what am I going to get to see. Expect during construction, tons of things going to change, right? Rightfully so, people say, whoops, I didn't think of that, right? Let's move this by half of an inch, no big deal. But still, things need to be updated and documented. And there will be easily 1,000+ records called quality records per structure. Have a good way of documenting this. And do not wait until the end of construction to receive any official construction quality record submittal, because you will be flooded and people will expect you to turn on a dime. Handover, that's the last one. Let me go straight to basically recommendations. It's like, do plan ahead. Think of how you, once you're done with construction, how do you certify and hand it back to the owner? Do not use that phase to start identifying the requirements. I've seen this over and over again. People saying all of a sudden start reviewing requirements or identifying stakeholders. That's just, everything was done before. Determine, what do I say here? Oh, at this point in time, it's not the time to identify how am I going to certify. This goes back to do plan ahead. So any certification reports, whatever you need, should have been identified as part of a handover plan at the very beginning. Plan for partial use possession prior to final completion. So there's going to be, everyone wants to start using things, right? The design builder wants to be able to say, I'm done here. So all of this, there will be, it's not a black and white, we're done. It's going to be a kind of done almost, but still do some work. Having said that, let me just summarize quickly. So I gave you an overview, right, of the motivation of why the presentation. Brief overview of what we had in mind and what when we hit reality. Some advice to people new to the industry is like, it will be different and tough. I can promise you that. What we started out with at the very beginning, 10+ years ago, the lessons learned, right, the results we had, basically what worked quite well, and then also some lessons learned, how we incorporated this into the SDLC model, showing you some examples, and then also basically phase-by-phase recommendations of what I think people should be doing. Having said that, back to you, Dale.
Oh, great.
Almost
Thanks.
10 minutes to answer some questions.
Yeah, absolutely. Thanks. And just a quick, I don't know if you can hear it or not, but quick round of applause from the gang. We could do the electronic applause, but I always like the audible. Yeah, that was great. Fantastic. I'll kick it off with a question because it's near and dear to my heart, if that's okay. And then others can jump in. On the gate reviews, because that was one of your bullets that you focused in on, don't let them get away with it. The problems that I've experienced are, well, I call it gate review politics. It's sort of kick the can down the road syndrome, or the idea of having if you rename the gate, you can kind of get away with kicking the can down the road. So we'll have what was originally PDR then becomes PDR1, then 2, and the idea is that by sort of tacitly acknowledging that you're kind of almost through PDR, then maybe somebody should get paid a little bit or maybe all of it or whatever. And I've found that without a really strong sort of QA ethic or QA oversight, that does seem to predominate, some of the larger projects I've been on. What did you guys come across that? And do you have any recommendations or solutions on how to avoid?
Unfortunately, it was even the other way around. I'll tell you in a second. So first, right, you remember, so we worked for 10 years and then had lessons learned, and now we documented the lessons learned, put them into that SDLC document, and made them part of 3+ contracts right now. So right now we are basically executing the new lessons learned. So it's probably too early a little bit of giving you some feedback. But some of the trouble parts is there is no 60%, there is no 100% for the project. It's by site, right? The way it's construction speaking, and they say, oh, we do some construction over here, and here we are fast enough or advanced enough, so we declare 60% completion over here, but in the other, area you might still be behind. So first, you really have to be able to break it up by site. That's why it's so important to know what are your construction sites or design sites. But the authority actually initially what I refer to as a quality milestone data plan, right? They were referred to as payment milestone data plans. So the whole idea was exactly like that. If you want to get paid, right, at this milestone, you better bring by all those deliverables, and then you get paid. And for whatever reason, the first contractor was able to convince the authority that's not really a requirement. And so it changed into quality milestone data packs. So it was actually done the other way around, yeah. And so, but that's the lessons learned. The good news, right? So we are, reverting back. But sometimes I just don't know why. Yeah, why is that? Isn't that kind of so obvious? But I guess it's obvious to systems engineers, but not really to the civil engineers, I guess. Yeah. So long story short, is it comes down to enforcement. If you don't enforce your rules, then there are no rules.
Yeah, exactly. Yeah. Thank you.
Mhm.
Let's see. Carrie has one here. I don't know if you wanted to just speak it, but she put it in the meeting chat there.
Yes, I'm opening.
I just put chips in my mouth, so sorry about that. I didn't think I'd get called though.
Sorry, Carrie.
No, it's all right. I'm on a couple of different projects. And Oliver, my question was, from your perspective, how well you think the authority has truly embraced your sage wisdom. We're not seeing it in actual practice. And your comment about the performance milestone is awesome. I think we all can buy into that, except for when they promote on time versus on quality in the form of their deliverables. And the performance metrics I've seen don't address giving them the right thing. It just addresses giving them the thing on time. So I just, I didn't mean to be flippant or facetious, but I do think the information is good. I think we have a long way to go to get the authority to embrace what you're saying. We need more champions, and we need champions at the project level as well as the program level, because this information my biggest concern is if for some reason there's no way to keep you on this project after December 2024. My biggest concern is who's going to champion this within the Sacramento office. I don't see your replacements yet.
So what can I say? It's so I'm as Dale said, right? I'm also a PMP, so that's what you describe as a triple constraint. It's like you can pick, quality, time, or cost, and pick any two. I think over time we raised like quite tremendously awareness of the whole idea of how things can be done better. My direct supervisor, Dominic Rollins, he came from the SNCF in France, building high-speed rail globally, is now within the authority, so he's highly promoting. He basically became a believer. So I think we are making progress, but as I showed you, it's like 10 plus years. So things take time. And I wrote a paper a couple of years ago on even doing VNV during construction, and there's 7 million people in the construction industry, and how many systems engineers are we? Yeah, so it's one drop at a time. It's all I can say. So you have to have the right mindset. You have to have the passion, but you also have to be realistic and be up for frustration any now and then. Yeah, because things don't change as quickly as you would want to. But we do have people, strong believers in the authority as well. Yeah. That's all I can say.
Great. Thank you. Thanks, Oliver. Yeah, I share Carrie's concern. And so I guess it probably, and this is maybe more of a social systems engineering working group discussion, but it kind of gets down to, I think, sort of reward structures. How are people rewarded? So if the leadership on the project is rewarded for on time and quality be damned, maybe that's an extreme statement, but roughly equivalent to what I've experienced, then that's what you'll get. People will respond to those reward structures. So
yeah, it's all about incentives, right?
But
the timeline is more important than the quality. Well, but don't be surprised.
Yeah, exactly. Yeah, we have another question here from the chat. We got time for maybe a couple more. Did we have the RAM requirements from the beginning?
Yeah, we actually did. So we have even program level, right, where we say, hey, by literally doing this the way it's supposed to be done. If you're familiar with EN 5126, it's about RAM in the rail industry. And one of the first things you're doing is looking it up, what was the achieved RAM performance globally. So we looked into, as a program, not me personally, into what is achievable in what was done in Spain and Taiwan and in Japan. And then we derived those RAM targets of saying, okay, that's practically, then we broke it up by how the contracts are structured, by train sets, by stations, by infrastructure. And then so the RAM targets were basically trickled down as RAM targets by contract. And then there was a whole slew of, here's what you have to do to manage RAM, right? We're writing a RAM management plan and all the likes. And boy, is that seems to be some real. We even to the point of RAM basically demonstration was saying, sorry, but you will have to replace a bearing at some point in time. So we actually asked for replacement procedures and actually demonstration. And you would not believe, I mean, you probably believe, it's fighting tooth and nail to get the design builder to actually do what the contract says. So it was done from day one, but it's very difficult to implement it. Yeah.
Yeah, no, right on. Yep. One last quick question, then we're probably out of time. Has the SE approach been applied to, whoops, it just went off my screen, to the signaling systems? Well, and I assume Sanjeev is referring to on the same project.
Yeah, so without, I have to be careful because if you go to the website, you will see that the authority is currently procuring some contracts, but not the systems contract just yet. But that SDLC will be part of that systems contract. And of course, they will have to do it. And then even in further detail, right, with concept of operations, the functional requirements, system architectures, and the whole shebang. Yeah. And we're actually pushing for even moving nowadays more and more towards model-based approaches.
Fantastic. Well, we're actually right at time. And on behalf of everybody that attended and asked questions and was engaged, and everybody else as well, thank you once again, Oliver. Always a high quality standard, at least from you anyway. Well done, sir. And we'll be reconvening. We're not going to do the third Thursday in December because it's too close to Christmas. So look forward to a flyer from the joint INCOSE Rail Interest Group and APTA gang on December 7th. So it's the, I don't know, I guess the second second Thursday, same time. So we'll get that flyer out to everybody on the various mailing lists as soon as we can. And once again, thanks everybody, and thank you again, Oliver. And everybody have a great rest of your day or evening, depending where you're calling in from.
Thank you. Thank
Thank
you all.
you. Thank you. Bye.
Thank you.
Many thanks.
Okay, thanks, Oliver.